Good morning, everyone. So I'm Sarah Weldon. I am head of product at Translation AI in Google Cloud. And I'm here this morning to give an overview of our translation portfolio, and especially adapting translation with our newly introduced specialized large language models, which are available on our translation APIs. So I'm going to start with why translation, and then I'll move through the rest of the agenda, which covers translation at Google, an AI overview, impacts of generative AI in the industry, and adaptive translation, which is our newest feature. And then I'll give a short demo and we can go through Q&A. So please feel free to start putting in Q&A and comments into the YouTube channel, and our moderators will convene it. Looking broadly, globally, there is a wide need for translation and localization in industries, as well as people really want to be able to read content in their own native language. And so it places a great deal of demand on companies, organizations, and translators to be able to cover as much content as feasible across hundreds of languages. There is certainly a set of dominant languages that are European and Asian, but there are millions of speakers globally, and you can translate into many, many different languages. So it would take 2 billion translators to localize the world's daily content into the 100 most economically significant languages. And today, there's a shortfall in the number of translators that could actually meet that type of demand. As content continues to grow worldwide, that demand will only increase, and more users are coming online and need to be able to read and understand content in their own language. It ties back to decision making and helping them do work and operate in their daily advancements. Companies need to be able to translate across many different modalities. It ranges from document translation to multimedia translation. Text translation has been the most consistent development area over the last several years, but even to customer service. And this is largely to be able to scale to serve as many users as possible in the media and content style that is most ready, consumable for that use case and that implementation. And so Google has been in this space for a very long time. Many people are familiar with the Android and browser applications that allow you to do translation in very familiar places. You could do it on your phone. You can do it when you're on any website. Just run it through Google Chrome and you have a little translate option in the URL, particularly if you imported the Chrome extension. But it's made many advancements over that time frame. So it was introduced in the 2000s. It advanced further with neuromachine translation, which was the first major implementation of machine learning with translation. And it's advanced further with being able to implement with our APIs. So companies and organizations can directly call the Google's translation models that everyone's familiar with, and be able to run translations in their own apps, in their own web applications, mobile applications, wherever their end users are. So it makes it all much more accessible across many different use cases driven by companies and organizations and not just by Google. Additionally, we've introduced being able to handle formats like document translation. And then most recently, being able to have end users be able to consume translation directly within a company with Translation Hub. In 2023, last year, we took on the advancements that we've been seeing both with our own technology in the industry with generative AI and seeing how that can really transform what we can do with translations. And so we see some great applications for large language models as bringing more flexibility and customization in real time. And that's what we want to enable through the translation APIs as well. And so if you look at our overall portfolio of offerings, you can see that we try and meet customers wherever they are. So you can integrate with our developer APIs. We have a very simple version of the developer API, which is the basic one. This is your best plug and play that allows you to move fast and quickly. It is a very simple implementation. So it doesn't have a lot of the features as Translation API Advanced, and it is stateless. So you can do text or HTML and language detection, and that is about it. But it allows you to integrate really quickly and easily with any app. Translation API Advanced has much more feature capabilities, which I'll talk about in a moment. And then we have our models that power the APIs, and that is our pre-trained models, which is our 135 languages across for HTML and text. But then you can also do further customization, and that's what we're offering on Translation API Advanced. So I'll go a little deeper into the custom model cases, but all of these are served through our APIs. And then we integrate them into solutions. And all of this is powered by Google Cloud infrastructure, scaling it up with the best-in-class GPUs and TPUs so that customers can both rely on high QPS, queries per second, as well as high availability and global availability. The basic features really are focused on making it fast and easy to use. So we have an integrated REST API. You can do it with the Google Cloud RPC call. It integrates with many other third-party platforms, such as translation management systems and content management systems. And it's really the best, fastest way to get started for customers with affordable pricing by character. Translation API Advanced, as I mentioned, is really about being able to do more controls. So to talk a little bit more about that, a lot of enterprises need terminology control. They want to be able to fine-tune with custom models if they have training data of source and target example sentences. And then they want to be able to use those models in formatted documents to be able to get a PDF translated or get a PowerPoint translated. And so all of that is enabled through Translation API Advanced. But as we are entering the area of generative AI, we want to be able to even further simplify custom implementations by enabling things with translation large language models. We have our custom translation platform with AutoML, and the primary difference to understand with AutoML is that you're doing a full fine-tuning. And so this means that you are going into our platform with your GCP project and importing a data set that is a set of source language sentences and a set of target language sentences. You want to be working with a pretty large data set in this case. So that's 30,000 examples up to a few million examples, because a lot of companies that do a lot of translation will have a pretty large repository of past translation memory that they would work from to create these custom models. And so that's really the target base for the AutoML cases, and they might have a lot of terminology that they're looking to enforce with that. So AutoML is your optimal path for terminology enforcement and retention, and for pretty custom cases where you might be doing healthcare research, or in cases where you might be doing financial data analysis, then you'll get better performance in the AutoML translation cases with that path. And so that you've seen what I've walked through, that you would have the two paths, a very simple path, and you also have a more complex path. All of this can be enabled through our APIs, and the idea is to make it as easy to use as possible for any third-party developer, company, or organization to just be able to leverage machine translation and complete the rest of their use cases. But we know that there's been a lot of advancements with generative AI. And so with all of the capabilities that are coming out with the newest, latest models, we want to be rethinking how can we do translation, not just as additional workflow cases after a machine translation, but also enhancing the machine translation itself. And so that's what our first level case is with adaptive translation. And the reason why this is important is right now, even though foundation models are offered widely and have a lot of language content available in them, they are still, because they are large and general purpose, they are both more heavily weighted towards kind of the highest resource languages, and they are often too large to serve at scale for the amount of content that you see flowing through them for translation use cases. And so right now, there's orders of magnitude difference in the latency that you see with the large language models that perform well for translation, or reasonably well for translation, and the models that you see for general machine translation. And when you're getting into translating articles and hundreds of segments, per minute or per hour, that latency really adds up. And so we wanted to make advancements with our large language models to create smaller, nimbler models that work well for translation cases, but can actually respond in real time to the content that's sent to them to adjust to get you better, more fluent, more stylized translations. Additionally, large language models, because they are still largely trained with more English data and some of the other high resource language data like Spanish, German, et cetera, they tend to not perform as well for more of the tail languages or even torso languages. So these are languages that might be have less digital content in the training data to work from. And so you see this drop off in the overall language quality. So with our general translation APIs, what you get with that is you can have more confidence in the language depth that you're getting. And that's why you see Google models offered on the leftmost side of this right-hand graph, which basically says this shows the machine translation vendors that provide the most domain coverage and the most language coverage across the different offerings. So this is the model that's going to perform the best for the most use cases and the most domains, and that's where Google has generally excelled. The left side graph here that I'm showing is really about the latency difference. So you can see the drop off between a large language model that's a general foundation model and the machine translation models that are the traditional translation models. And then so that's part of the road that we started going down with adaptive translation and our translation LLM, is to make a smaller, faster, and more language robust set of language models that we can offer through our API, and offer it with an integrated API solution to get better translations on the outside. And so what adaptive translation essentially is, it allows you to import a short data set of source and target translation examples. This is used to give the large language model more context to understand how, all right, my light turned off, how the preferred customer prefers the translation to be implemented. And so the content is sent to the large language model in real time at the point of inference. And then it is used by the large language model to provide an output that is more relationally similar to the source content that you have imported. And so you can see some gains in fluency and style, particularly customer-specific style or company-specific style over our general machine translation models. But you don't have to go and do a full fine-tuning path that you would need to do with AutoML translation. So it finds a benefit between these two areas. Additionally, you'll see some quality gains because it is more grounded in reference source data sets that are supplied by you as the end user. And that's integrated into the API path itself. So the two things that we've done to invest in providing that feature is essentially fine-tune from foundation large language models, make them smaller and fast. And although they're still not quite as fast as the pre-trained models, just to be candid. And then the second thing is having this intelligence built into the API so that when you provide examples, it's actually selecting the best examples that are in close proximity and high quality to the source content that you want to translate. So it's taking that relevance and matching it. And what the findings are from doing like kind of some customer tests on it, this was done with We Localize, one of our partners who did this as an experiment with us for the AMTA conference we had in fall of last year, the American Machine Translation Association. And so from their initial findings on it, we found that AutoML translation can still better handle terminology errors, but adaptive translation is actually really excelling on reducing style errors. So you get overall better fluency and accuracy with adaptive translation. As you can see, it's a higher point case with the accuracy and fluency score from adaptive translation. And in particular, it's taking on the client-specific terminology and company style better than the other examples with AutoML or with General NMT. And so that can be very beneficial, in particular for marketing type content. You would want to use this more with things that aren't as terminology sensitive. So that's kind of where it has like a good fit with things that are either more style or more company content or more style based along the lines of marketing, and not as like deep technical, like maybe a user manual for a device. That you might still be better off sticking with AutoML translation. So I'll switch now to a quick demo, and then we can come back to the deck and we'll go on from there. So let me load my other screen. Okay, great. So just to orient you all on the how to navigate to here in Google Cloud. So if you're coming into the Cloud Console and you see things through the menu, you would want to come all the way down to find the translation product view. And from there, you can select it in. You can also pin it, which I always have mine pinned, so it's showable right there. And then it'll take you to our dashboard page. Within the dashboard, you can either select adaptive translation from the Get Started or from the left-hand navigation menu. And you can see also that our other products in the translation portfolio are viewable through that. And then the path in here is essentially allows you to either import your data set through a local file or from Google Cloud Storage. I will show it from Google Cloud Storage just because it's a little bit easier to see it in the screen. And then we can go from there. But you can do it through either case. And we support both TMX and TSV files. And in this case, I have a set of financial data sets. So these files are all about 2,500-ish examples of source and target sentences, just to get you a sense of the file size. And Once you import it, you can actually see just how quickly the API takes it in, detects the language, and it does an additional analysis, initial analysis on the file itself. So it's very fast. In this case, it's a French to English example. And let me just grab my translation. All right, to get my mouse to the right browser window. And then thanks. So this is my example translation from French, and we'll run the translation pretty quickly. The things that I would point out here while it's running is the temperature, and the examples are 2 additional parameters that you can set, and you can compare it with the NMT model. I usually keep this clicked on by default. Temperature you generally want to have set to 0, so we keep that as the default because that keeps it as a more direct, more deterministic translation. Whereas like as you move up the temperature and get it into like the order of 1, then you could end up getting more creative results, but also less accurate translations. You increase the potential for what we call is like distance from the original translation. So coming up with other synonyms or other words that might not be your intended version. So coming back to this, the large language model has a more concise output than the NMT model, which is our pre-trained model. And it also gets the acronym, like, which is one of the more financial acronyms that's actually present in the example data set. It includes it here correctly. So it has the new business value as the translation, and MBV is the acronym for it, whereas you can see that there is an error case in the NMT model. So that highlights essentially the implementation of it. You can see it's very simple. This is callable through the API. You can support it with multiple sentences. It doesn't handle long context in terms of a broader context window. So this is still sentence by sentence translation in terms of how the model is fine-tuned. So that's one of the limitations with it. In terms of languages that we support today, we support English, Spanish, French, German, Italian, Portuguese, Chinese, Korean, and Japanese. And this is all in general availability. We will be working on expanding this in the future. So I'm going to switch back to my slides. So that is the end of the demo. And so when you're looking at our translation API, one of the questions that can come up is, so like, how do I select which translation I'm doing for which use cases? And a lot of this is like best fit that is determined by the end user and by the company that's deciding how they want to allocate their resources. So translation API is really for using fast, high quality translations with reliability. And consistency across a lot of language pairs. It is fast, it is simple. You can add more features with the advanced API, but it is just intended for high scale. AutoML translation is you still want fast and high quality, but you have a lot of customized content, and you want to do things with technical domains, and you have training data to support that. So this is the path for being able to do it with custom translation. As I mentioned, you would want this for more technical and domain deep content. And then adaptive translation is probably for more marketing content for right now. But also it can take on some domain adaptation. It's just not as high on enforcement as AutoML translation. It is somewhat slower, but we are improving the performance on it, as we keep progressing along. So I do encourage you to test with it to see if its performance is meeting your needs. We've done a lot to improve the model speed recently in particular. So if you tested with it in the fall, I would expect you would see some good efficiency gains if you tested with it again. Just in the most recent weeks. And then if you have a smaller set of training examples, but you do want some customization or you want some style adjustments, then adaptive translation can be a great path for that. And it's all very easily integrated into our API, so you don't have to do a lot of prompt engineering, and you can have confidence in the translation output as long as your training data, the input data that you're importing is also good quality. For the general large language models, you can still use these. They do support translation. It will work. And you can do it if you want less expensive translation because they're priced for very broad use cases. So being able to use them in many different examples at high scale, but they are also, as I mentioned, a lot slower. So it comes at those trade-offs if you're trying things out with them, but you can certainly try. We have some great large language models on Vertex with Palm as well as Gemini. So those are available to use on the Vertex platform. We have some more links here. I do include AutoML as well as one of those links. The beginner's guide actually provides just some good general guidance on working with your data sets, and that would still be relevant to our adaptive translation. Not as much on the size of the data sets, but more on what you should look for in the quality. As well as how to handle the number of examples. And then a couple of blog posts and listings for adaptive translation. So this is more just to kind of provide some guidance on comparisons between basic and advanced. We can go back to it if we need to. And then resources and what's next. So I think I can pause it here for a moment, and then we can take a look at questions as well. All right. So let me progress this side to Q&A too. So looking at the first question from Dirk, when translating PDF, PowerPoint, images, etc., does the solution just extract the text and then translate it, or does it keep the graphical format and shape? So it kind of depends a little bit on the file that's being sent. But in Translation API Advanced, you can, for PowerPoints, the graphics will be retained. Depending on the way that the graphic is imported into the file, if it's like static versus a chart, that the chart, it's like live editable by text, is treated like text, so it gets translated. If it's a hard file like an image, it may not be translated, but it will be retained. So that would still be kept in the PowerPoint, and similar for Word doc. PDFs, you have native and you have scanned. And so we try and keep as much of the graphics as possible on the native. On scanned, it's a little bit more challenging sometimes. It kind of depends on how complex the layout of the graphics and the PDF are, because it is returned back in a PDF format. In terms of the underlying solution, it does quite a bit of extraction paths, as well as kind of cleaning and rebuilding the documents. So it does try, like the intention is for it to retain as much of the content and format as possible. Some very complex formats can be a little bit harder to implement. Flowcharts, for the most part, if it's in PowerPoint, will be retained. The graphics will be retained, and the text will be replaced for a translation. When translating PDF containing center heading split into 2 lines continuation, same center heading as a new line and translate it. Okay, we'll take a closer look at this one. And then just looking at the STARD. When is the regional language support for other Indian region languages for custom model creation going to release? So I think there's some additional languages targeted in the roadmap. I don't know how, like, what listings of those are amongst the different Indian regional languages. And this is for like our general translation models, which ultimately get supported in Translation Hub as well. And then some other questions in here. All right. I think we have covered quite a bit of the questions. I think we can wrap up. And I do encourage folks and I just also wanted to state the product is in general availability. Oh, great. Is adaptive LLM guaranteeing the privacy and not used for training to the baseline of the model? Same question for Gemini Pro. So in terms of, there's actually like a terms of service on generative models. When you send your content to our APIs, it is not training the models themselves. So it's not used to update the models directly. Your data is kept within your project. And so, yes, that privacy line is retained. So there's within GCP, whenever you import data sets, these things get isolated within your project, and any content that is used is only used in the time of the translation itself. In the API, you can import your data set, and then your data set is listed as part of your project so that you can use it for future translation requests with adaptive translation. So it is saved, but it is saved only in your GCP project within Google Cloud Storage. So it's not something that Google generally has access to. And then when you send content to the model, it is not retained or used to train the models in any way. And that would be the case not just for adaptive translation, but for our large language models generally. So for Gemini Pro as well. And it is not used for training the baseline models. Any other questions? All right. Thank you, everyone. Thank you, Lauren, for hosting, and Advait for helping with moderation as well. All right. Thanks, everyone. Ending the live stream.